Here.
Okay, no worries. Oh, okay. Sorry about that. It's gonna.
There you go. You're good. It's all good.
I didn't save it because I didn't want to save my
speaker name.
Copy. Yeah.
I present to you all.
I didn't want to save my speaker copy. I didn't want to save it on the server, so I saved it locally, and that's not picking up. But that's okay.
You're completely fine.
Okay. Well, you know my name. My name is Pam LaHoud. Thank you for that introduction, Tim. And you can, since it's not on the slide, I'll dump it into the chat. You can find me on Twitter at SQL Goddess. No, Teams is trying to cancel, just send. Teams is trying to find that person at Microsoft now. There's my Twitter. So I am the lead, the program manager team lead, the manager of the PMs that work on SQL Server on Azure Virtual Machine. What I have for you today is kind of an intro into how Azure VMs work and how you can think about sizing an Azure VM if you're planning on migrating one of your on-prem SQL servers to Azure or a number of on-prem SQL servers to Azure. There are some differences in the way you really have to think about sizing. And that's one of the reasons why I put this presentation together, and I've been delivering it at a lot of conferences. In fact, we're going to deliver something similar at the PASS Summit coming up in November as well. I'll give some advance apologies. I didn't have time to update this deck. There are some new improvements that have come out in the past few months. So I'll just mention those where they're applicable and let you know that there will be some changes coming. So if you see this session being delivered in the future and you're thinking, I already saw that, stay tuned, because there's actually some changes coming and some announcements hopefully we'll be able to make at PASS coming up in November. So one more thing, please feel free to ask questions. If you want to unmute and ask them verbally, or if you want to drop them in the chat, that's fine. I'm happy to take questions in line. I find they're a little bit easier to answer when we're still in the context of that conversation. So please feel free to interrupt me. And if you want to go off on a tangent, this is your meeting. It's a user group meeting, right? I don't have any commitments to cover any amount of content. So if you want to go off on a tangent and have a conversation, please feel free to unmute and ask, and we can do that. This day is for you. I've been talking about this content forever, so. Okay. So when you are, is Azure called EC2 or instances? No, EC2 is the AWS version of this. So EC2 is the compute that AWS offers. And then we also have a couple of other Azure SQL offerings. Actually, it's probably a good question for me to kind of talk about Azure SQL in general. I don't think I have that content in here, but I'll talk briefly. Azure SQL has 3 different offerings within it. One is Azure SQL DB, which pretty much everyone, when you say Azure SQL, that's pretty much what they're thinking of, Azure SQL DB. And that's like a standalone database that's a full PaaS, platform as a service solution, which means Microsoft manages everything for you except for what you put in your database. So basically except for your application. So we take care of like backups and high availability, and we give you an SLA, and all you have to worry about is putting in your data and your tables and your indexes and your queries and your store procedures, and you take care of all of that, and we take care of all the underlying infrastructure for you. But it's a single database model, which means some features and functionality in SQL Server are not going to be available there, particularly things like cross-database queries, because you've really only got one database. So in order to give a PaaS solution that has a little bit more compatibility with on-prem, we have another offering called Azure SQL Managed Instance. An Azure SQL Managed Instance is a full instance of SQL Server where you can have multiple databases, and it's much closer to what you get on-prem. However, it's still a PaaS solution, platform as a service solution. So that means we still manage things like backups and high availability, and you can even get like GeoDR and things like that. Like we do all of the infrastructure management for you. And again, you just have responsibility for your databases and your code. So there's a little bit more functionality there that you have on-prem versus Azure SQL Database, which is kind of diverged a bit from the on-prem product, but it's still a PaaS service. It's not fully compatible, however, and one of the things that a lot of people find is that they want a specific version of SQL Server. They want the exact box product, and they also want to have control over how the system is configured. So that's where SQL VM comes in. So the formal name of the product is SQL Server on Azure Virtual Machines, but we usually just call it SQL VM or Azure SQL VM. And so there isn't really a different engine here. It's the same engine that you're used to on-prem. It's just that we provide some value add services on top of that to help you manage your SQL servers and virtual machines. So you can just spin up an Azure VM and you can put SQL Server on it. But in order for that to be an Azure SQL VM, you have to do something called registering that instance. And that's where you can either check a box in the portal that says find all my SQL servers and register them, or you can manually register your VM, and I can post some links later in the chat for how to do that. And then once you do that, you actually get an Azure SQL Virtual Machine blade, and we give you some additional management capabilities, things like a health assessment or best practices assessment, automated backups, auto patching, things like that. We just give you some kind of value add services on top. So the reason why we have a whole team for this, you would think, okay, it's just SQL Server running in a VM. What's different? Believe it or not, it's a lot different because when you're on-prem, you have full control over the hardware that you buy, right? And you buy hardware for usually a 3-year cycle, sometimes even longer. So you're really planning ahead. You're purchasing maybe big iron, big servers, or you're in a virtual environment where you carve out, a lot of CPU and memory for each one of your SQL virtual machines, and you can decide how much memory and CPU you carve out. It's totally up to you because you own the whole thing. You may have a really big SAN that's really fast, and you've got plenty of fast storage and lots of IOPS and throughput to the point where you're not even thinking about how much your workload is actually generating. And you may be in a situation where you're monitoring servers, and when they get above 50% CPU, you get anxious because you're like, I'm getting high CPU, right? But that's, if you think about it, that's 50% of the server that you're not actually using. Do you really need that? When you're on-prem, it's okay, right? Because you've bought that with the idea of growth in mind, and you expect to be not at the top of what the server is capable of. But when you come into Azure, you're purchasing hardware differently. You're not actually purchasing hardware. You can think of it as renting hardware. You're renting hardware. You're paying for it by the minute. So it's really important to think differently about how you're going to size. It's not usually the right answer to just take whatever you have on-prem and put that in the cloud, and just build it, match like for like CPUs and memory. That's not always the best way to do it, because what you could end up doing is spending a whole lot more money for capacity that you're not using. And the nice thing about Azure is once you get there, as your workloads start to grow, you can always size up your virtual machine. It's a relatively easy process. So we really start thinking about things differently. And one place where customers really have a challenge is when it comes to IO, because again, most people are just carving up, I need, 10 terabytes of storage, give me 10 terabytes of storage. And they're not thinking about, well, how much IOPS and throughput is that generating? How many IOPS and throughput do I need? Because most of these storage systems that you have on-prem are incredibly fast, and they're massively oversized for what you need. And you just don't even have to think about it, right? In some cases you do, but usually it's more like you hand it off to the disk team and you tell them, hey, this is not performing well, I'm not getting good enough disk performance, go fix it. And they'll figure it out for you, right? You're probably not thinking about how much IO throughput my SQL Server application is generating, right? And so when you come into Azure, you really have to think about it that way, because when you select the hardware that your SQL Server is going to run on, you have to know ahead of time how much of these things that you need, because you have to pay for them each individually. Remember, you're renting this hardware, and there's all of these caps and limitations that you're not used to facing on-prem. When you're on-prem, you can just have as much as you need because you're on a shared SAN, and it's usually fine. There's plenty for everyone to go around. when you're in Azure, you're going to get capped if you get close to the limits on each one of your VMs or on each one of your disks. So that's what we want to talk about here. All right, so what are your options in Azure Virtual Machines? Well, there are literally hundreds of different virtual machines that you can choose. And so it can be a little daunting trying to figure out which one do you go with. Now, Azure organizes their infrastructure offerings by like family. So we have an entry-level family, which is the A series VMs. We have a burstable family, which allows you to burst resources. That's the B series VMs. General purpose and confidential computing, that's the D series VMs. Compute intensive, F series. Memory optimized, these are the E series and the M series. GPU accelerated is the N series. High performance computing, H series. And storage optimized is the L series. So the ones that we generally recommend that you focus on for SQL Server are the memory optimized and the general purpose. These, now you know SQL Server is a memory intense application. So having a memory optimized is what most people want. But there are some maybe entry-level servers or maybe some of your development servers that really don't need as much resources. Those you could go with a general purpose VM, but these are the ones that you want to focus on for most of your SQL Server workloads. I would say the only other one that you might look at is the L series. So there's a new LSV3 series, which is interesting. The problem with the L series is they have lots of really fast NVMe storage, but it's ephemeral, which means you can't guarantee that the data is always going to be there. Obviously, that's not great for database workloads, but there's some niche places where that might be relevant. But for the most part, you're looking at memory optimized or general purpose. And out of the memory optimized series, the ones that we really love, you can see it's kind of highlighted in green, are the E series VMs. So the M series VMs are big iron, like 400 cores or more, lots and lots of memory. And they're I mean, when you look at them and you think, oh yeah, I definitely want to run my SQL Server on those, but they're incredibly expensive. The E series are more reasonably priced and they're smaller memory, but much more suited to your average SQL Server workload. So we really like the E series, and particularly the EBDSV5 series. This VM series is what I call the double sprinkles VM. I call it hashtag double sprinkles VM. This is a VM series that we worked with Azure Compute to design specifically for SQL Server workloads. And the difference between this series and other VMs is it has much higher I/O throughput. So we really liked the EDSV4 VMs. That was the one we used to recommend because they have a 1:8 core to memory ratio, which is good for most SQL Server workloads. And they had a decent amount of I/O throughput. But we said we have customers that really need more throughput, and they need more throughput at a lower core count. And so that's where this EBDSV5 series comes through. It's got the highest I/O throughput available in Azure. And it's got that 1:8 core to memory ratio. And for a lot of customers, they can actually reduce their costs just by switching from that old EDSV4 series to this new EBDSV5 series, especially if they can stop using constrained cores, which I'm going to talk about in a second. So I see a question from Saeed. What's the difference between compute intensive and high performance compute VM? It's really, if you look at the series documentation online, we have documentation for each one of these families. It's the processor architecture that I think is different. And I think those F series VMs have like really fast, like L3 cache and stuff like that. Like they've got it's different types of processor architectures and things. So what you should do is take a look at the documentation. We fully document the kinds of processors that are in this hardware and all the different hardware that's attached, like if it's NVMe or you know whatever special hardware is associated with each one of these families, that'll all be documented. So basically the way this works in Azure is we have a couple of different hardware classes that are used, and the family of VMs is carved out of that hardware class. So all the VMs will sit on that particular type of host. And so the family documentation will tell you what that host machine looks like. Okay. So I'll let you guys take a look. If you follow this URL, that will take you to my blog that talks a little bit more about why this is such a great VM series and how this can save you money. We also recently did a performance benchmark with GigaOM where we showed that we have better price performance than AWS EC2 instances, particularly their R5B series, which is comparable to this EBDS v5. Same memory to core ratio, same level of IO throughput. So I'll let you guys follow that link and take a look at that information. And we will have some new information coming out soon because we have a new storage type that I'll talk about in a minute. Okay, so let me explain the naming convention because this is something that confuses a lot of people. It's like alphabet soup. Like, let me come back here, right? EBDSV5. That's a lot of letters, right? Like, what do all these letters mean? They actually all mean something. So that first letter, that capital E, that's the letter that stands for the family and the subfamily. So the family is like whether it's memory optimized. So E series, M series, right? And then there's, the D series for the general compute. And then there's, it's D, like DC is for the confidential computing. So D series, general purpose, C for confidential computing. And so that's the family, the capital letters. And sometimes there's 2 capital letters in the beginning and sometimes there's 1. It depends on the family name. So if the letter is capital, it's part of the family name. Then the next is a number, and that's the number of vCPUs. So in the EBDSV5 family, if you're looking for an 8-core VM, then it's E8 BDSV5. Okay, so then there will be a number right after the family moniker, and that will be the number of vCPUs that's in that VM. And then all the letters after that have some kind of feature designation. So if it's a lowercase a, it's an AMD processor. The B in the EBDSV5 stands for bandwidth, for IO bandwidth. D stands for diskful, which means it has a local SSD that's available inside the VM. As usually it's a D drive, but it's a local temp drive. It's ephemeral storage, which means that if the VM migrates to a different host because of self-healing or because of maintenance, you will lose the information that's on that drive. I means it's isolated, which means there's only 1 VM on the host. So those will be your larger VMs that take up all the CPUs on the host. There's a little holdback for Azure backend processing, but you get almost all the CPUs in the host. L is for low memory, M is for memory intensive, T is for tiny memory, S is for premium storage capable. When you're looking at SQL Server in Azure VMs, you always want to make sure there's an S. You need that premium storage. And there may be a few other letters. They're sometimes introducing new features that you might see additional letters for. So the ones that are most important for us for SQL Server, the B for bandwidth in that EBDSV5, the D for diskful. We like to have that local SSD because it's great for TempDB, because TempDB is also ephemeral. So it's a way that you can leverage high-speed, locally attached storage for TempDB, which is great for performance, particularly when you have a heavy TempDB workload. So we like those VMs that have the little D in them for the disk. And this is all documented, so feel free to click through to this link here, and you can see the documentation of the naming convention. So there's one more thing I wanted to talk about, which is particularly relevant for SQL Server customers, and that is the constrained cores feature in Azure VMs. So when you see a virtual machine size that has a dash like this, so standard M32-16, what that means is it's all the specs of the 32 vCPU VM, but we only give you 16 cores available. Now, why would you want that? Let's say you don't have enough memory on the M16 VM. The M16 VM, you only need 16 cores, but that M16 VM just doesn't have enough memory for you, and or it doesn't have enough IO throughput. You really need the memory and the IO throughput from the M32, but you only need 16 cores. You could just get the M32 VM, and that would be fine, but then you have to pay for 32 cores of SQL Server licensing. And if that's Enterprise Edition, that's a huge amount of cash that you have to lay out for cores that you know you don't need. So what the constrained core VMs allow you to do is get those specs of the M32, but only 16 cores, which means you're only paying for 16 cores of SQL Server. So this is a great way, if you don't have exactly the right mix of number of vCPUs and memory and IO throughput on the VM that's offered just basic, then you can hopefully get one of these constrained core VMs. And this will allow you to reduce your licensing costs, but still get that benefit. So that's anything that has a dash and a second number. That's what that means. That's a constrained core VM. Now, not all VM series are available in constrained cores, but the E series ones that we like are not the EB series yet, because they already have a lot of high IO throughput, but there may be constrained core sizes available coming soon for those EBDS v5s. But this is something that customers, SQL Server customers in particular, often use in order to get the right mix of core to memory and core to storage. Okay, so let's talk about how provisioning works. So like I said, Azure VMs have limits. So you are going to be what they call capped when you hit a certain throughput limit. And that capping happens it could happen at 3 different levels. So here's how storage works in an Azure virtual machine. So there is a host machine, and the host machine has a hypervisor, and all your VMs are running through that hypervisor, right? So there are also what we call managed disks. That's what we mostly recommend SQL Server customers to use, managed disks. And these are offered by Azure Storage. So the managed disks can be attached to a VM, and the storage traffic for that managed disk goes across the network. So that's VM level network provisioning is what governs how much IO your virtual machine can push over the network to a managed disk. Now, it's a separate limit. Each one of these VMs offers IO limit separate from the network throughput limit. But understand that this IO, since you're going out to another service in Azure, even the IO is going across the network, but it's a separate capping limit than the actual network traffic capping limit. So there's actually a virtual machine IO limit. So that's what we call VM network level provisioning. That's a cap at the VM level for how much IO throughput you can push. So then we also have disk level provisioning. So those managed disks that you attach to the VM, they themselves also have a limit. So each one of those disks will have an IOPS and a throughput limit for how many IOPS you can push and how much throughput you can push to that disk. So if you have like 10 disks attached to your VM, each one of those disks will have its own limit. And then also they'll be governed by the VM network level provisioning, because all 10 of those disks together can push, much more throughput than a single disk. So you could get capped on the disk level, or you could get capped on that VM network level if all the disks added together are pushing more than the VM is capable of. Because remember, all this is governed by networking, right? So there's a disk level provisioning, a VM network level provisioning, and then there's one more thing called SSD level provisioning. So the host machine has some number of SSD drives attached to the host, and those are presented to the virtual machine as local storage. So each VM running in that host will have some amount of local storage carved out for that virtual machine's use. And so that will also be capped, again, to protect other things on the host, right? So that's what we call SSD level provisioning. So that storage, like I said, is usually the D drive. That's locally attached storage, and it's ephemeral, which means it'll go away if the VM migrates to another host. But it's also used for something called Azure Blob Cache or host caching or disk host caching. What else is it called? Azure Blob Cache, disk caching. It's called any number of things, but this is a cache that's available on the host that makes your storage a little bit more efficient, because remember, we're going over the network to get to your managed disks. So if we can cache some of that locally, it's going to be faster. So hang on, sorry, I got to snooze over here. Okay, so this SSD level provisioning governs not only how much IOPS and throughput you can throw at the D drive, but also how much you'll get in the cache. And this could be important because we actually have separate limits. There's the cached storage limit and the uncached limit, which is your remote storage limit. So this is why you really have to think about what IO your SQL Server is generating, because you could get capped at any one of these levels. So let me tie this back to something concrete. So this is an example of documentation for one of our Azure VM sizes. And each one of the size families will have a page, and it'll have a table for the resources that are available. This is a little bit outdated. Some of the wording has changed since then. I got to replace this. And also this is one of our older VMs, but it works the same. So for any one of these VMs, this max uncached disk throughput IOPS and megabytes per second. This column represents how many IOPS and how much throughput you can get at the VM network level provisioning. So this is how much collectively the VM is allowed to do. No matter how many disks you have attached and what the limits on those individual disks are, added together, you can't exceed this limit. Now, many of the VMs today also have bursting. So you may see a second column for uncached burst limits, and that's how much you can burst. But keep in mind that bursting is only available in 30-minute chunks. And if you've burst to that limit for 30 minutes, then you get kept back down at the regular limit until the burst bucket fills up. So in other words, you need to stay there for a long period of time before you can burst again. So you may see bursting here too, but let's just, I don't use bursting to size my VMs. I think of bursting kind of like overdraft protection on your checking account. Like it's nice to have in case you accidentally have an extra withdrawal, but you don't want to rely on that in your budgeting, right? Same kind of thing for sizing. Bursting is good to protect you from unknowns, but you don't want to count that when you're sizing. So that's your VM network level provisioning. And then we have your SSD level provisioning. So this is your max cached and temp storage throughput. So this is how much you can drive through the cache and use for your D drive. And so again, it's the same number of IOPS and then throughput. And then the old documentation had cache size and gigabytes, but we don't document the cache size anymore because it might be different for each host. So we no longer document the size. And then the temp storage, this is how much temp storage you have. So if you're planning on putting tempdb there, which we do recommend, keep this in mind. This is how many gigabytes, or sometimes it's in terabytes, that you have available in that local drive. So make sure you have enough to host your tempdb if that's your plans. Okay, so that's the SSD level provisioning. And then disk level provisioning is on the managed disks themselves. These will each have some limit. So we generally recommend P30 drives. And with P30 drives, you get 5,000 IOPS and 200 megabytes per second of throughput. So that would be the disk level limit. So if you take this E8DSV4 and you look at the numbers in the chart here, this is how they would map out to that diagram of how the IO works. So you can see there's 12,800 IOPS and 192 megabytes per second of uncached throughput. So that's this VM level provisioning. That's how much the whole VM is capable of. And then you've got your cached and temp storage throughput. So that's the 77,000 IOPS and 485 megabytes per second. And that, you can't see my mouse, can you? I should probably be highlighting with this, right? Or laser pointer, that'll work better. Okay, so here, this is your is here the cache, temp storage, and throughput. This is your uncached storage, IOPS and throughput, and then your managed disks, depending on what size disk you choose. Okay. So where do you put your database files? So we recommend that you put your transaction log files on a managed disk with host caching equals none. In other words, don't turn on caching. So we recommend read caching only, because for SQL Server, writes have to be flushed to the disk in order to guarantee durability. So SQL Server cannot use write caching. So we recommend that you have a separate drive or a separate pool of drives for your log files so that you can turn off caching. Otherwise, you're wasting cache. So for your data files, we recommend you put those on cached managed disk. We usually recommend a pool of P30 drives to get to the IOPS and throughput you need at the disk level. And here you would turn host caching to read-only because the caching allows you a lot more IO throughput. So you can see here, you've only got 12,800 IOPS at the VM level, but you've got 77,000 IOPS in the cache. So if you can make use of the cache, you'll actually get much better performance. And again, this will be lower latency because it's locally attached. So we do recommend for your reads that you turn on read caching. So you need to have a separate disk pool in order to be able to do that. And we recommend P30 drives because you can only turn on host caching on drives that have less than 4 terabytes. So it's either P30 or P40 that will allow caching. Okay. And then, like I said, we recommend that you put tempdb on the local drive because then you're not wasting your precious remote throughput on tempdb. And also remember, this SSD is super fast because it's locally attached. So you get nice fast storage for your tempdb. And since it's ephemeral, you can't put data files there. So it's good to put tempdb, which is also ephemeral. So this is how we recommend thinking about sizing your VM. Let me pause and ask if there's any questions before I keep going. Because I know that was a lot.
All clear, looks good, Pam.
Okay, let me take one more sip of tea then. Okay, so let's talk a little bit more about storage, and I want to talk about an innovation that's recently released or recently released in private or public preview. So these are the different managed disk offerings that we have today. Standard HDD, standard hard drive, and standard SSD are not fast enough for your SQL Server workloads, and they don't have enough IO and throughput. Standard SSD might be okay for some of your dev workloads. So if you need a cheap VM for your development workloads, as long as performance is not a concern, then these would be okay for dev, but definitely not for production workloads. So just ignore those and focus on premium SSD. Premium SSD is the best choice for SQL Server. It's got good performance. It's not the fastest disk. UltraDisk is the fastest disk. If you need sub-millisecond latency, UltraDisk is great for that. However, it's incredibly, incredibly expensive. So most customers don't opt for UltraDisk. The nice thing about UltraDisk is you can configure capacity and IOPS and throughput separately. Whereas with premium SSD, you have to choose which kind of disk you want, and that comes with a fixed number of IOPS and a fixed amount of throughput. So UltraDisk gives you a little more flexibility for configuration, but it's like I said, it's just super expensive. So we recommend premium SSD. And remember, I was talking about that caching. So you have to be a P40 or lower in order to be able to do caching. So we recommend that. But also, you can do disk reservations if you want to get better pricing. So if you reserve hardware in advance, and you can do this reserved instances for VMs and reserved storage capacity, you can get a better price. So the reservations start at the P30. So this is one of the reasons we recommend P30. It's kind of a sweet spot for a balance of price and performance. So the new thing I want to talk about is something that was announced in public preview a month or so ago, which is called Premium V2. Premium V2 is kind of a mix of Premium SSD and UltraDisk. Premium V2 allows you to do the same thing you can do with UltraDisk, where you configure capacity and IOPS and throughput all separately. So you get a slider basically. So you choose how much capacity you need, then you choose how many IOPS and how much throughput you need. The nice thing about that is it allows you to customize the right mix, and you'll get a better price that way. Also, Premium V2 is faster than Premium SSD. So it's a nice mix between Premium SSD and UltraDisk. And we've been doing some testing on it. And I think it's going to be a big win, especially for transactional workloads. The only issue with Premium V2 that I see is that it doesn't support caching. You can't do that caching. But I think because the latency is so low, for your transactional workloads, it's actually going to work out to be better, particularly if you leverage the EBDS v5 VM series, which already also has high I/O throughput. So if you don't need that high I/O throughput from caching because the VM already allows you to do high remote throughput, then that together with Premium v2, it's just going to give you the best price performance for your SQL workloads. So this is what we're going to be coming out with messaging soon, that EBDS v5 plus this Premium v2 is absolute hands down best price performance for SQL Server. So stay tuned for that Premium v2 announcement coming up. It's already available in public preview. If you have VMs and you want to try it, you can sign up for the public preview. Okay, but for now, and also for older VMs, for VMs that have higher cache limit than on-cache limit, then Premium SSD is probably still going to be better. Okay, so here's how the Premium SSD works. You've got, like I said, P30 and P40 are generally the sweet spot for us. So you've got a specific capacity, and then you've got a set amount of IOPS and a set amount of throughput for each drive. And so if you need more than this, then you just pool them together. You attach multiple managed disks to the virtual machine, and you can create a storage pool using storage spaces to create a simple stripe pool. And then you can get more I/O throughput for your virtual machine. And actually, if you use the marketplace image for SQL VM and you use our deployment experience, we actually configure all this for you. You just tell us how many P30s you need and we'll build the storage pools for you. So that way you don't have to know. It can be a little bit complicated. It involves some PowerShell because all the options you need are not supported in the GUI. You really need to do this through PowerShell. So we handle all that for you if you just use the SQL VM deployment experience. So I recommend that if you're a little unclear on how to configure storage pools. Okay, so that's your disk level provisioning. And then UltraDisk, as I said, you pick the VM size and then you can configure IOPS and throughput up to certain limits. Actually, these limits are old too. I believe UltraDisk now goes up to 4 gigabytes per second or 4,000 megabytes per second. So so these limits have changed again. I got to update that slide. Okay. So let's understand capping. This is the, we might not have time to get through all the slides, but this is the main one that I really want to get through, is understanding how this capping works, because it can be a little confusing having all these different limits. Okay, so let's imagine that we have our SQL Server and it's sitting on an E8DS v4 VM. And let's imagine that we've attached 3 P10 disks. So when you attach a managed disk to a VM, it's referred to as a data disk. So when you're looking at a virtual machine in the Azure portal, in the virtual machine blade, it'll say disk. So it'll say like, how many data disks do you want? When you're talking about data disks, that's just to differentiate them from the local SSD or the OS disk. So this is just managed disks. They just call them data disks. So we've attached P10s. So remember, the VM limit here is 12,800 IOPS and 192 megabytes per second of throughput. But those P10s are only capable of 500 IOPS and 100 megabytes per second of throughput. So let's walk through this animation. So let's imagine that our SQL Server throws 10,000 IOPS at the virtual machine. And let's imagine that this is how that's spread out. It's 1,000 IOPS to one of the drives and then 4,500 to each of the other drives. That's how we break up the 10,000. So these drives are not capable of that much IOPS. So they're not going to serve back 1,000 IOPS or even 4,500. They're only going to give back the 500 IOPS they can do. So what's going to happen here? You're going to start queuing IO. So if you look at perfmon, you're going to start, building up a queue on these disks. Because they can't process that much I/O. And so obviously that's going to result in slower performance. You're only going to get the 1,500 IOPS. That's a lot less than the 10,000 you asked for. So naturally, this is going to result in slow performance. And that's severe enough that you'd probably notice it. So obviously, P10s would be a bad idea here. Okay, so let's go up to those P30s. So remember, the P30 can do up to 5,000 IOPS and 200 megabytes per second of throughput. So now if we have the same situation with the 10,000 IOPS and breaking it up with the 45, 45, and 4,500, 4,500, and 1,000, then this would be fine because each one of these P30s is capable of 5,000 IOPS, right? So that's fine, no problem. There's your 10,000 IOPS, and you shouldn't see any queuing here and no performance issue, at least none related to the disk. Okay, so this would be fine. And also keep in mind that this 10,000 IOPS is still less than the 12,800 that the VM is capable of. So we're all good here. All right, so now let's imagine that the workload increased on the SQL Server. And now instead of 10,000 IOPS, we're throwing 15,000 IOPS out there. So now the disks are capable of this. This is totally fine. So 5,000, 5,000, 5,000, no problem. These disks can serve back 5,000. You're not going to get capped at the disk level for this kind of a workload. However, the VM is only capable of 12,800 IOPS. So that's less than the 15,000. So you're not going to actually get that much throughput. The disks won't cap you, but the VM will. And so again, you could start seeing queuing here, depending on how long you're running at a pace where you're outpacing the capability of the VM. If this is just a spike, two things could happen. Either your application will absorb it, you'll queue for a little period of time, and then you'll recover. Or if you're on one of those burstable VMs, maybe you could burst, and as long as it's a short period of time, you won't see any queuing because the VM will let you burst above that 12,800. So that also might happen. But if this is sustained, if you're constantly doing this level of IO, then you're constantly going to be queuing and you're going to start seeing performance issues. Now, whether that results in a performance issue in your application, it's hard to say. Maybe the slower IO won't be a problem, but you would definitely need to test that. And you probably don't want to run at that rate for a long period of time. You would probably want to size up to get higher IO for this VM. You don't usually want to stay throttled. It's okay to be capped or throttled. Some people call it throttling. They like to call it capping, but most of us call it throttling. It's okay to be capped for a short period of time. That probably won't be noticeable. But if it's long-term, then you might be getting like chronic slow performance here. Okay, so this is the kind of thing we have to watch out for. So in this case, you would need to either size up the VM, or in our case, there's something else we can do on these EDS v4 VMs, and that is caching. So we'll talk about that. Actually, you know what? No, I want to talk about that now, and then I'll come back to the. No, okay, I'll talk about this now. Sorry. So monitoring IO capping. If you already have some Azure virtual machines and you want to know whether you are getting throttled or capped, there are some metrics that you can look at in Azure Monitor, and you can build yourself a dashboard on your portal that tracks these metrics. You can also go into Azure Monitor and you can set up alerts. If I remember correctly, they charge money for alerting, but the metrics themselves you can look at for free. So the ones that help you diagnose disk level capping are data disk IOPS consumed percentage and data disk bandwidth consumed percentage. So that's your IOPS and your throughput. So that'll tell you how much of your capped limit you're consuming. So if these are always at 100%, then you're constantly being capped at the disk level. And then you'll have a separate counter for each instance of disk. So if you have 10 managed disks attached, there'll be 10 separate counters for each one of those disks. So you can see whether you're being capped at the disk level. And then at the VM level, you have VM cached IOPS and VM cached bandwidth. And then you have VM uncached IOPS and uncached bandwidth. So this is your remote storage limit. The uncached is your remote storage limit. And then this is your cache limit for IO that's going through the cache. Okay. So these are metrics that you can look at to see whether you have capping issues. Okay, so now I'm going to skip the demo because we're going to be short on time here. So understanding host caching. So I really want to get to this because this is really important, especially if you're running on any VM size other than the EBDS v5. EBDS v5 caching is not as important because the remote throughput limit is so high. But on most of the VMs in Azure, the cache throughput is way higher than the remote throughput. So it's really important to leverage caching in order to be able to take advantage of that higher throughput. So host caching is configured at the disk level, and you set it here. So it says host caching, and you can set it to read only, read write, or none. So your OS disk is automatically going to go read write, which is fine. You can just leave that alone. But for your disks, you want to make sure your data disks are set to read only cache, and your log disk is set to none. Because remember, I was talking about that we can't take advantage of that write cache because we have to write through to the drive to guarantee durability. So make sure, this is another reason why you need to separate data from logs, because you want the cache settings to be different. So data disks should be set to read only and log disks should be set to none. And by the way, again, if you use our deployment experience in the Azure portal, or if you use one of our ARM templates for the SQL Virtual Machine images, we configure this for you. We set host caching for you appropriately. We choose the, we attach the data drives and set the caching. We build the storage pool. We do all of this for you. So you don't have to remember all this. You just go through the deployment. When you go to the SQL storage configuration page, you just tell us how many P30s you want or P40s you want. We build everything for you and set the caching appropriately. We ask you, like, what do you want for your data files? What do you want for your log files? And do you want your tempdb on the D drive? So we'll do all that for you. Okay, so how this works. So our VM sends a read request. And if you have caching turned on, it's always going to go through the cache first. So it's going to hit the cache first, and then it'll pass the read request on to the uncached disk if the data is not available in the cache. My Teams just went black. Oh. Okay, that was weird. Can you guys still hear me?
Yeah, we can see your camera. We can see your slide.
You do? Okay, weird.
Yeah.
My whole screen just went black. Okay.
Oh, I know.
Okay, so can you see the arrows going now too?
Yeah, we can see a little red
good.
thingamajig.
Good. Okay, perfect. We're good then. Okay, so if the data is not in the cache, the VM sends a request, hits the cache, goes out to the disk, and then comes back and returns your data with the response. So in this case, this read would be counted towards both the VM cached limit and the uncached limit, because you went to both. You hit the cache and you went to the remote. So this would be a read request that would come out of both your cached and your uncached limit. Now, if the data is available in the cache, then this read is only counted towards the cached limit. So this is one where it comes in handy that the cache limit is higher than the uncached limit, because this allows you to get more IOPS out of your VM, because we were able to serve it from the cache and we didn't actually have to go to the remote disk. So only the VM cached limit, not the disk limit and not the uncached limit on the VM. Okay, now a write always has to write through to the disk. So a write is always counted towards the uncached limit and the cache limit. Write always hits both those limits. Okay. So here's the benefits of the host caching. Back to our little diagram of capping. We've got our SQL Server sends 15,000 IO requests, but this time they're cached requests going through the cache. So we're not even, if we assume that all of these were being served from the cache, we wouldn't even hit the disk. We'd just go to the cache and come right back. But now, if at least some of those get served from the cache enough to overcome the VM limit, then great, no problem. No VM or disk capping here. And in fact, the ones that are served from the cache, we don't even go to the disk for those. So this allows you to go beyond this 12,800 IOPS and come out of the 77,000 IOPS. So it's way higher in the cache. So if you can leverage the cache, then this is great. Now, how much will you be able to leverage the cache? Again, your mileage may vary. It's going to depend on your workload. We usually say on average, you can assume about 30% boost in performance from the cache. So about at least 30% of your reads will come from cache only and will never go to the disk limit. That's not a precise number. Again, it's really heavily dependent on your workload, but we almost always see a benefit to this cache, particularly for transactional workloads. Okay. So summarizing, choose the right disk. We do recommend that you use a premium disk for most of your workloads. P30s. For log files, you can go higher than P30s because you don't care about caching. You want to have caching set to none, so you can go higher, but generally P30s and P40s so that you can leverage caching. Ultra disk if you need super low latency, but remember it's expensive. Ephemeral disk for tempdb. And then when it comes out, premium V2. So take a look at Premium V2 for your workloads, particularly if you go with the EBDS v5 VM series, because that VM series actually has higher remote throughput than cache throughput. So everything that I just talked about is a little bit different with EBDS v5 because you don't need that cache limit because you have such a high remote storage limit. So for that, Premium V2 is great, gives you the best price performance. So do enable the host cache on every VM size except for EBDS v5. Write acceleration, this is something, I'm sorry, I think I have some animation coming up here, yeah. Write acceleration is something that's only available on M series. So if you're using M series VMs, definitely turn on write acceleration for your log drives because that's going to give you lower latency on your log drives. And then storage configuration best practices. So we have a lot of this documented best practices. If you go to aka.ms/SQL we have all of these best practices documented, and also we have that built-in storage configuration that's part of our deployment experience. So if you deploy your VMs using a marketplace image and our deployment wizard in the portal, we do all this for you. So that's your best bet for configuring your VMs. Okay, any relationships between storage pool and using multiple database files? That's a good question. So storage pool is just really allowing us to pool together and get more IOPS and throughput for our data files. You don't need to have multiple data files. Multiple data files is not going to increase throughput on a VM or even on-prem in most cases. Unless you have multiple data files that are spread across disks, you don't really need multiple data files. So what the storage pool does is it allows you to avoid having multiple data files. If we didn't have the storage pool, what you would probably have to do is attach like a multiple P30s, and then you'd have to divide up your file groups into separate files and put one file on each P30 drive. So what the storage pool does is it just does that for you. It stripes your IOs across the disks without you having to do it in files. So that's just using, having multiple files would be only if you didn't have the storage pool option. So I think it's one or the other. Okay, got a couple minutes left. I'll just talk about how to map this with your workloads. So what you want to do is measure your application performance. So if you're migrating an on-prem system into the cloud, into Azure VMs, do some monitoring and see how much IO and throughput your application is generating. So you can get this from perfmon. Reads per second and writes per second are your IOPS. Disk read bytes per second and disk write bytes per second is your throughput. And then your latency would be average just seconds per read and seconds per write. So your uncached IOPS and megabytes per second, the uncached limit, you want to basically look at all of your transaction log reads and writes, plus your data file writes, and let's say about 70% of your data file reads. Because remember, we know we can leverage the cache for, let's say, about 30%. So you can assume that the cache helps you about 30%. So you want to make sure that your uncached IO limit is higher than whatever this is. So look at your maximums, look at your averages, and try to make sure you stay under that uncached limit there. And then for cached and local, this is your tempdb reads and writes if you put tempdb on the D drive, plus your data file reads and writes, because all of your reads and writes from your data file are going to go through the cache. So you need to make sure your cache limit can support all of that. Okay, so this is how you can kind of map your current workloads with everything that I've been talking about. And oh, by the way, we actually have tools that will help you do this. We have a SKU recommendation tool that's built into either the database migration assistant or the inline migrations, which is part of Azure Data Studio. So Azure Data Studio has a migration plugin that you can use, and that SKU recommendation tool will help you collect this data, analyze it, and then it'll recommend a VM series that's appropriate for you. So it'll actually give you a couple, like 3 choices of sizes that might work for your particular workload. So that's a great tool. If you want to ignore everything I said and have a tool that does it for you, that's the tool to get, the SKU recommendation tool that's part of our inline migration tool. Okay, we're right at time. So if anyone has any questions, I can stay for a minute or two and answer questions or drop them in the chat, or you can always ping me on Twitter later if you have additional questions. Yes, that's why all the databases are using a single database file. Yeah, we generally recommend it. You don't need more than a single file if you're on a storage pool. Yep. Great.
Any other questions, guys? Pam, thank you. Oh, well, we got some more to say here. All right. So while Arjun's typing up his questions, I just want to thank you again, Pam, for taking your time out of your day
Absolutely.
to talk to us about this topic. I know I have a big customer here on the East Coast, well, global really, who is encountering issues with newly migrated workloads, SQL workloads on Azure VMs. So this comes in timely for me.
Yeah,
in particular.
it's a pretty common problem. That's why we put this together.
Very good, very good.
Yeah, actually, Tim, do you have a place where I can upload the slides so they can see them? Or
If you can send them to me, I'll put them in our upload section.
okay, great, I'll do that. How would we monitor Azure SQL VM in Azure as like on-prem? That is actually a really good question. We are working on that. We don't have a great solution for monitoring holistically on VM. Azure Monitor has some stuff that you can do for like the basics, but it doesn't have SQL Server specifically. There is a tool called Perf Insights, which you can use, which has some SQL Server rules built into it, but it's not really proactive. It's more reactive. So you run it on a periodic basis, and it has some rules that'll run that'll say, hey, you're being throttled or whatever. So we don't have a really great comprehensive solution. Incidentally, SCOM actually works in Azure. So if you have SCOM on-prem, you can monitor your SQL VMs using SCOM if you have that. But we don't have a really great comprehensive solution yet. We're working on it. So stay tuned. But for now, your two best bets are Azure Monitor and Perf Insights.
Good. I'm just I'm repasting some of the information we pasted in the front part of the chat of the user group meeting, specifically where the recordings are and where the slide downloads are. So once you send me your slides, I'll just drop them in our OneDrive.
Sounds good. All right. Thanks all. Have a great day and a great weekend.
Thank you, Pam. Thank you very much. Thanks, everybody. We'll see you next month.
Yeah. Bye-bye.
Bye-bye. Stop the recording.